easier to use software like Discovery, which will start to do a bunch of this stuff for you, like to clean up the geometry, have automatic contacts, define your materials, if that information is available from a CAD model, and it will do the mesh for you. And this is really great. Like, this is a really important thing for the software to be doing, because it lets novice users who might not know how to do all of this stuff start to get into the software and use it, and it increases adoption and makes FEA more accessible. And for expert users, it saves their time doing these like routine tasks for them and lets them focus on things that actually demand their skill set. So automating this stuff is really important and really good. So what more can we do to make the FEA workflow easier? It's kind of difficult to see because the software doesn't have knowledge about your supports, your load cases, your joints and bolt connections. So supports and load cases, the software can't really do because it doesn't know ahead of time, what you want your boundary conditions to be. But what about the joints, bolted connections, and maybe even contacts and materials side of this? The thing is that a huge percentage of users are designing assemblies, designing systems, whatever, which rely heavily on pre-made parts that they're purchasing from other suppliers. And the supplier is going to have information about their bolted connections, joints, bearings, materials, all of this stuff. They do have that information. So our suggestion is that the industry can adopt this approach where component manufacturers provide analysis information to the customers, which offers even further opportunities for the analysis workflow to be more efficient. And if we look at CAD models, this has already happened in the industry, right? So like this screenshot from the MakeMaster car website, we have this download option here for the SolidWorks model. So we can do something similar. This is some example website where you select the products you want, and then there's this download button, and this gives you finite element analysis information and the CAD files together. So the sort of proposed workflow then that the user will have is that they have their design sketch, bill of materials, and then they download that package of the components in the bill of materials from this database. And when they unzip that, they find that they have CAD models and an analysis script that goes with it. So then they create their CAD assembly, and CAD assembly is tied to the analysis script. Like that script knows about the CAD assembly, but you can still make customizations to those CAD models if you follow some rules. And it's not completely rigid that way. And then you import your assembly into your analysis software, which in this case is Ansys Discovery. You still have to apply those supports and loads yourself because there's no way, that someone else knows about that ahead of time. But then all you have to do is import this analysis script that was provided to you in the package, and your simulation is ready to go. So that's what the workflow would look like, in this paradigm. So what does that actually look like in practice? So here we have this example where we have these 80-20 T-slotted aluminum extrusions, and these frames are made entirely of prefabricated supplier-provided parts. And they are quite a complicated structure that has all of these bolted connections, all these pieces interacting. It'd be difficult to do this analysis sort of by hand. So if we look at this so-called chair structure, let's see what that proposed workflow would look like. So we start with the sketch. We have a bill of materials. That's all of the components that we're going to need, and then we can download them from our supplier portal. And then we have all of our files that we need, and that includes this analysis script. So then in our CAD software, we have all our components. We make our assembly, and then so that's all just completely normal. And then we import that into Ansys, and we have this extra step where we're running this script. So this script was provided, just download it, we just copy it in and run it. and then we're done. So we have our simulation. So here I would have a slide saying we have some comparison between this, and you can show the experiment and show that this approach really works and stuff, but it's not really done right now. So then going from that, the benefit of this workflow. So I did this same analysis myself with and without the script to see how long it takes. And it took 27 minutes for me to do it without using the script. And this is time spent, it's kind of annoying. I'm trying to select all of these faces in the model and stuff, hide parts, whatever. This is a tedious task, and it's error prone. It'd be easy for me to miss something, click on the wrong thing, whatever, and not even notice. So it's using a bunch of time, and there's room for error. Whereas with the script, this took 3 minutes. I just imported, select my faces for my boundary conditions, and run it, basically. So it's a really huge, huge benefit. And for me, this is a model that I already know, and I already know what my bolt preload force is supposed to be. But it's easy to imagine that the user doesn't have that information. They might not even know how to set up the model at all. Or if they do, it takes you far longer than 27 minutes. So having these steps automated is a really, really huge benefit.
David, I am dumbfounded. This was a fantastic presentation. All right, this is a fantastic presentation. I think let's complete it and let's pitch it to them once again. That's wonderful. Very nice idea. On page 2, right? I think you said requires experts, but it's not there in the text, so you can just add that. And I don't know. There was a gender. Yeah, number 2. So that's just I think it'll improve your presentation. It's already very good, but I am really dumbfounded. Now there is a strategy. There is a strategic decision that you guys have to make, not me, the people who have actually worked on this. Do you guys want to do this as a business? As you amongst yourself, I'm just asking. I think there is a semblance of a business in here.
I mean, I just started a full-time job. I don't really have time.
All right. It is important for me to make it, bring it to your notice. There is a problem, and you have a solution, and you have the expertise. This solution is not something that anybody and everybody can implement. It gives you that domain specificity to basically generate solutions, right? You can create the script for the various people. You can also sell the scripts that have been generated. So there could be a number of ways. I think things will be lean for a year or two, but thereafter you guys will, as your library grows, you will become more and more sought after, and it could be good. But anyway, that's just my point. It is for me to bring it to your attention, nothing else. So Chris, I think we should arrange for a meeting with ANSYS.
Yeah.
And showcase some of this. And David, you can present. I think near the end, right, when it comes to the experimentation, please give Ben an opportunity to talk as well. It's more for experience, not for anything else. Co-ops are about experience, so give him a little spiel. And Ben, do not tremble in front of the audience.
Okay.
So I think that would be very good. That would be very good. Well, any feedback, Andrew?
Sure. To address the comment regarding approaching it from an entrepreneurial perspective, I'd be totally open to that. And I was just thinking, there's a whole bunch of business models surrounding Photoshop as a software suite that people sell presets for. I know this is obviously a lot more complex than that, but there is companies out there doing that, and all they really create is scripts that, let's say, improve workflow. and get you 80% of the hard work done off the bat. The other thing, David, I wanted to commend you on is I think the last couple of years of your life as a grad student, you've been working to make FEA more complex. So this probably really went against your natural, um, let's say,
Instincts.
predisposition for doing things. So kudos to you on doing a really good job at explaining it in a very simple way. That's easy for anyone to understand. So you did really good with that, and I think I'll just echo what Sanjeev said. That's totally a great job. Well done.
Okay, thanks.
So David, for the meeting with ANSYS, when do you think you'd be ready? Like, when's kind of the earliest I could ask them about meeting?
Oh, and we don't want to delay it past 17th or 18th, right? Like the term ends around 20th. So let's just show it to them and keep going.
So do we want to just plan for it in that final week then? Just push it as late as we can and kind of aim for the 16th to the 18th?
That's up to David.
Sorry, 1 sec. Let me just.
I still need Ben sent me some images for doing the strain calculation on the actual extruded assembly that David was showing there, the displacement contour plot.
Yeah,
I can coordinate with Ben. We might have to take a few more images
okay.
just to get good ones for the presentation. But yeah, I think it should work fine.
It's, by the way, the two of you, three of you, right? The experts here. What if, see, we already know the shape of the part. The CAD model is known, right? So we already have a camera that is taking pictures of the 3D shape, right? Is it possible for us to even envisage that in the future, 5 years, 10 years down the road, the verification step would also be in the loop?
Yeah, no, I think that's the end goal is to have a feedback mechanism where you can calibrate the model with experimental data. That's partially kind of how the relationship with Microsoft was forged. I think to use the dev kit to do that exact same thing. So that in my opinion, that's the holy grail of this type of workflow.
So maybe I think we should make a presentation to Microsoft as well.
So Sanjeev, we've got one on the books for September 7th already. Of how we plan on,
No, with our friend, I forget his name. What's his name? Like just a special meeting with him.
With Mike?
Yeah. But I think, David, you might have to add this little bit of kind of closing the loop, right? I think you'll have to do this in conjunction with Andrew to kind of add the precept device. It is research, but I think it could be a very potent addition, and it could be a direction that could be taken. Anyway, you guys are sitting on a gold mine. What you do with it is your business, but it's my duty to point it out. And by the way, the university has the rights to use it free. just adding it there, right? I think at least I made you guys laugh. It's very difficult these days to make people laugh. Over the last week, anything that I've tried has fallen flat. So thank you. I think you have just boosted my morale.
Well, that's good.
So.
I think going back to Chris's question about scheduling, it probably just makes sense to do it in that last week.
Sounds good. Yeah, I'll reach out to those guys and see.
Yeah, and if Mike is okay with having a presentation, or if his boss wants to attend, that's fine too. Andrew, please, can we add this last little bit where we are showing that once the analysis is done, the closing of the loop will be done using precept. But this is again, there's an AI model to be generated. There is this closing of the loop would be very, very powerful.
Agreed. Sure, not a
Sanjeev,
problem.
did you want me to include Steve Elias just out of personal interest, or sure?
Very good idea. Very good. Anybody in FEA who might be interested in something like this? I think the people, the research groups, right? Do you think there is any interest? I didn't think so. I didn't think so. Anyway, very well done, guys. I'm really, really proud. David, you wouldn't mind sharing this thing with us, right? The presentation?
Oh yeah, for sure. I can share it.
Yeah, just send it to Chris, and you'll make the final presentation, and then we'll see where we had to. You might have to make one or two more, but that's
Okay.
that's where we sit. Very well done. I wanted to kind of it was in my mind, this thing, right, as to how we are going to prove that whatever we have done, is it good or not, right? There is another thing, and I think you owe it to yourselves to do it. I think there is a conference paper in this, what you're writing, like a little white paper.
Okay. I don't really know what that would look like.
What you said in the presentation, just follow that concept and put it in text. I will take it from there.
Okay.
All right.
Okay.
Basically, some of the things in the verbiage and the things that you said, right? That's your domain, not mine. So if you will put that in, that would be very good. After you've done this, send it to Andrew. Andrew, you put your 2 cents worth in, and then you send it to me, and then we will go from there.
Okay.
All right. We may include the guys from ANSYS as a courtesy, but that's, what that is anyway. So I don't need to spell it out. All right. So we have 3 or 4 action items. I will leave them to you. Very well done, guys. This is good stuff. And well done, David. Well done, Andrew. And well done, Ben. That's lovely. Ben, does this all make sense to you now?
Yeah, it makes a lot more sense.
Excellent.
So the real question is, are you going to use ANSYS in your capstone?
Oh, he's not. Not as yet. I don't think.
Depends on what my group comes up with, to be honest.
Yeah. Do you have a group and an idea already?
We've been over the fall term, we've been meeting up and talking about ideas. Nothing set yet, just because I feel like it's kind of dangerous to decide now, because if there are regulations or things we can't do, or also just limitations because of people taking options.
Yeah.
Then it could be just a waste of time if we decide on something and it's we can't really do it.
That's okay. That's very good. So you are ready for your capstone now? I thought. So you're in 4th year now.
I'm going to 4A in the
4A.
fall.
All right. Good. Well, I think if David has converted you into finite elements, that's a contribution to his area. All right. Okay, guys. Everybody have a great day, and we shall look forward to another meeting soon.
Ben and David,
Chris,
if you want to just hang out for a minute or so after, if that's cool.
Okay.
Chris, can you give me a shout, please?
Yep.
Ben, so I imported, or thank you for taking those photos. The load increments look good. The only thing that is going to be problematic is I think you took 2 images at each load level, which is good, but they're jumping around almost in terms of I don't know if you're holding the camera with your hands, but
yeah, I saw that too. That was an Nan to take it because I'm not on campus anymore, so I got
okay.
to take it from
So
me.
maybe I'll follow up with her. She saw me do it the first time, but yeah, it's not gonna work unfortunately with
yeah, I could tell him.
Okay.
But I think I'm not sure how he did it, but when we were doing together, he saw. But basically, we had like extrusion kind of wedged between it onto a chair so it wouldn't move, and I taped my phone onto the extrusion above it so it wouldn't move. I just had to set zoom as well,
Okay.
so I just clicked the buttons. I didn't actually zoom in and out between takes.
Okay. Cool. All right. That works. I'll follow up with them.
Okay, so you're gonna follow up, yeah, so I don't have to talk to him, or do you still want me to message him?
No, I can follow up with him.
Okay, sounds good.
Cool. Yeah, David, great job again. I just wanted to say how good that was.
Yeah,
Thanks.
Congrats on the job too. So,
yeah,
Yeah.
congratulations.
Thanks.
okay. We'll talk soon, guys.
All right.
Bye.
Sounds good.
All right, see ya.